So population proportion. Express the following confidence intervals. We have P here in the form P plus or minus E, where E is the margin of error. So we can see here that P, if we get the midpoint, 0.333 and 555 gives 0.888 divided by 2, 0.444 is going to be the midpoint. So we've jumped from 0.444 to 0.555, a jump of 0.111. So what can we say is equal to this 0.111? 1.96 multiplied by the square root of P times 1 minus P over N is going to be equal to this 1.111. In this question we're just asked to write it in the form P hat. So I'll write here P hat plus or minus 0.111. Straightforward enough. We can see P here is going to be 0.8. So this is going to be P hat plus or minus 0.1. P in the middle here, can't exactly see, it's going to be 621 and 233 is going to be 854. So the midpoint of that is 427, and I jumped to 621. So that's a jump of 194. So this is going to be the midpoint 427. And actually that's what they want here, isn't it? They want the midpoint of them too. I'll just rewrite these two. We got 0.444 plus or minus 0.111 is the format they want this in. This was 0.8 plus or minus 0.1. This one becomes 0.427 plus or minus 0.194. And the last one between 607 and 713, we're jumping 106, so we need to jump 53, which would get us to 660. And yeah, 53 and 660 is 713, so this is going to be 0.660 or 66, whichever you prefer, plus or minus. And we said we were jumping 53, 0.053. That's question 1. A sample is used to estimate a population proportion. Find the margin of error, in this case, E, that corresponds to the given statistics. N is 500, X is 150, and a 95% confidence level. We have 3 95s. No, they're all 95s here. Okay. So what they're saying here, this X is like success. So 150 out of 500 is my success. 15 over 50, which is 3 over 10. 0.3, and therefore 0.7 is failure in this case. So we're going to have 1.96 by the square root of 0.3. You can see it's going to be 0.21 by 0.7 divided by N, which is 500. Will give me E in this case. So E, the error for the population proportion, is going to be 0.040, 0.04 for part 1. And you can see here what we should be able to jump straight to the formulas. We've 800 out of 1,000 in question 2, so that's 0.8. 1.96 by the square root of 0.8 success, 0.2 failure, over 800, no, over 1,000. And that's going to be equal to 0.0248, 0.0248. C, 300 out of 600, but this is the max value. We're going to see, we'll use calculus with this formula in another video. 1.96 by 300 out of 600, 0.5 by 0.5. We're going to see this as the max value, because you can see P times 1 minus P is a quadratic, P minus P squared. It's going to go up it's going to have a max value up here. Have to differentiate and let it equal 0. Over n for question 3 is 600. So 1.96 by half, 5 and 600 is 0.4. And finally in D, we're going to have 1.96 by the square root of 20, but this is tiny, 20 over 1600. 20 over 1600. 2 over 160 or 1 over 80. Okay, well I'll type it into the calculator like this, 1 over 80, so that's going to be 79 over 80. And this is going to be 1600. And that's going to give me 0.0054. So don't be afraid to write things in a format where your calculator will do it for you instead of having to write out all the decimals.